Okay. Hello everyone. Hope everyone can hear me. Today I will present the results of me and Professor Jurgen Pfeffer's work on the topic of hate speech classification in Bulgarian. I will begin with a short introduction on hate speech in general, go over our approach, how we gather data, how we labeled it, and which classification models we used, and then I will conclude. So of course, hate speech classification online specifically has been a problem ever since the advent of the internet, really. Instant messaging and online forums allow for anonymized and really instant spread of hate online. And this has been problematic because of a variety of reasons. So there has been a connection between hate speech and hate crime has been established. As you can see on the graph here, this is just one example. Of course, there have been multiple, but here specifically a connection between Facebook posts on a certain right-wing political party's Facebook page and attacks on refugees during the Syrian refugee crisis can be seen. The red lines correspond to the correlation between them. So this has not gone unnoticed. There has been an increased attention towards hate speech and hate speech detection. As you can see here, in the past 30 years, the number of publications has grown exponentially. So while we have research on hate speech, it has been mostly focused on English and more represented languages like German and Spanish, I think. So hate speech in Bulgarian is still a problem that is not explored at all. And hate speech in Bulgaria specifically is a bigger problem than usual. Another example here is from a report done by Foundation Mission Salvation. They analyzed about 1,500 social media posts, again following the Syrian refugee crisis. And more than 50% of the posts they analyzed were negative. So following from that, it seems that there are two problems in Bulgaria in terms of hate speech prevention. The first of them is the detection of hate speech, and the second of them is law enforcement. Of course, this work aims to address the first of these two issues. So the goal of this work is to first collect data, to label it, and to create and evaluate different classification models. So I will now go over the data, how we managed it, how we gathered it, the sources, the labeling process, and the models that we used. So what is good data? What data would we like to have to perform hate speech classification? So we would like to have informal data, which just comes up in a natural conversation, if possible, text, of course. So this is a little hard to do. Of course, what comes instantly to mind is Facebook or Twitter. Those are the best possible sources, especially in Bulgarian. Facebook, Twitter is not that common, but Facebook is extremely big. So according to a study, as of February 2022, there are about 4.5 million Bulgarians on Facebook. So that's more than 60% of Bulgarians have a Facebook account. Those numbers are extremely big, of course. However, Facebook has the problem that it is protected. You cannot get the data. So we couldn't really use Facebook data, so we have to resort to other sources. And to do that, we contacted the biggest Bulgarian forum, which is Bega Mama. So Bega Mama was kind enough to provide us with 4.5 million opinions, which is a huge corpus. But as we started labeling it, as we started going through it, we noticed that people that make posts in Bega Mama are not that hateful. So we had to resort to other sources as well, which had a better representation of the positive classes. So we scraped another famous Bulgarian website, Jurgen, which is basically a collection of jargon words or phrases in Bulgarian. There we found a much better distribution. And as well the Pagan Nationalists forum, which is a right-wing political party forum. Also had a much better distribution. So initially we used 6 classes, of course, neutral, profanity, rudeness, sexism, racism, and other types of hate speech. We focused on these classes specifically because they allow for the best distribution. We noticed that those have better representation. And as I said, initially we started labeling on the basis of opinions. So those are multi-sentence texts, really. But then we realized that hate usually occurs in a sentence, in a single sentence. So we decided to split it sentence-wise and continue labeling the sentences. So we had to clean the data, of course. Pagan Mama uses BB code as a native on their website, so we had to remove all of that. We had to remove HTML text, URLs, punctuation, stop words, of course, and numbers. And we also made the text lowercase. So we, in terms of pre-processing, we tested grammatization, stemming, different levels of stemming, and of course, different types of vectorizers. So we focus mostly on TF-IDF here. You will see that in a few slides. Yes, because the data is imbalanced, we had to try out different oversampling approaches. So the first one that we tried out was implicit oversampling, so-called implicit oversampling, which really just adjusts the class weights based on how it adjusts the loss function based on how many samples we have from each class. The second one is an algorithm called synthetic minority oversampling technique. As you can see here, this is a visualization of the algorithm. So what this algorithm does is it just selects a random point between 2 samples from the same class in vector space, and it adds that sample to the training set. In terms of models, we used both classical machine learning models and a few out-of-the-box neural network architectures. We did not really go in depth with the neural networks because of time constraints, but we also included them. So here you can see category distribution of all of the classes. So in total, we labeled about 108,000 sentences. So a pretty big data set. However, so this is a log scale plot. The x-axis is a log scale, and you can see from this that it is extremely imbalanced. If we sum the number of non-neutral sentences, we still get less than 2%. So at this stage, we realized that we cannot really perform multi-class classification. So we resorted to binary classification, and we combined all the classes into one. The main metrics that we used is F1 score, and correspondingly precision and recall. And we also have a brief honorable mention of balanced accuracy, which is a more practical, I would say, metric. We used the 75 to 25 train test split because this allowed for a better distribution in the training set. Yes, so here, so this is the evaluation of lemmatization, stemming, or no pre-processing at all. So as you can see here, so we evaluated them on logistic regression, a normal logistic regression, and we used 2 different vectorizers on top of that. As you can see here, the difference is not that big. They are mostly 1 or 2 decimal places after the comma. So the difference is not that big in terms of pre-processing. However, stemming tends to perform best from what we can see here, or no pre-processing at all. This this can have a variety of explanations. It's just an interesting thing to see. In terms of vectorization, we used, again, different types of vectorizers. This is actually only for the classical machine learning models. Of course, for the neural networks, we didn't use them. Here you can see that the multi-gram character, term frequency, and word document frequency vectorization worked best. So we decided to go forward with that. The word vectorizers just didn't perform as well. So in terms of neural networks, we used 5 total neural networks. We used a simple multivariate perceptron with nothing pre-trained. We used word-to-vec embeddings, pre-trained word-to-vec embeddings, with 3 fully connected layers afterwards, and also with convolutional layers before that. We also used Flare NLPs, stacked embeddings, which includes, I think, 3 pre-trained embedding models, and a character-level convolutional neural network, which we took from a paper by Yamikun. You can see it here. This is actually the most complex neural network that we used. It has over 80 million parameters. It was also the slowest one to train. So these are the results of the classification. A few surprising things were that the biggest network actually performed the worst. The Flare NLP network, which combined the most embeddings, worked the best, which is not a surprise. And the other networks underperformed. So we will see a bit later when we talk about balanced accuracy that this ranking changes a little, because some networks and models focus on precision rather than recall. For the classical machine learning models, we focused on a variety of models. Of course, we tested out random forests, logistic regressions, support vector machines. All of them were their hyperparameters are optimized. We also trained a dummy classifier, which is just a point toss between the two, because here a very naive implementation of an algorithm would have a very high accuracy, but we tested out with that one. So we trained all models on the normal dataset and also on the oversample training dataset and compared them. So here are the results. So this is a precision recall for all of the models. You can see that the logistic regression and the linear support vector, the support vector machine with the linear kernel performed best. This can be also seen on the oversample data set. So this one is without oversampling, and this one is with oversampling. In both cases, the logistic regression and the support vector machine performed best. With the support vector machine performing a little bit better in both cases. What was surprising was that even with oversampling, the classifiers performed worse. We do not really have an explanation why this happened, but it is a fact. So, and as I said previously, we will have a brief look at balanced accuracy. So balanced accuracy, for those who don't know, is the mean of the recalls for each class. So the true positive rate and the true negative rate divided by 2. So here we can see something that is a bit surprising, or maybe not that surprising, but word-to-vec with the convolutional neural network actually performed best, and it was one of the worst models that we looked into before. And our best performing model, which is the support vector machine, performed actually the worst. So this is because the linear support vector machine focuses on precision rather than recall. So that kind of pushes the balanced accuracy score lower. But it was still surprising to see because if I were to use the hate speech classifier in a practical setting, I think I would prefer to use the balanced accuracy metric over the FL score. So again, this raises some questions about how models are selected. So this was, these were our results. There are many ideas for future developments. This is the first paper on hate speech in Bulgarian. So we hope that this kind of lays a solid foundation for future research. A lot more data is required to get better results. Here I have mentioned just a few ideas of how it can be improved. So training our own sentence or wording banks is one option that we didn't have time to do. Also, data augmentation to increase the number of positive samples could also be used if we use the thesaurus and add synonyms. Of course, social network features are also an option if you have age, gender, etc. as feature that can also help. However, that is a bit more theoretical concerns in that regard. And of course, last but not least, the initial goal of this work was to perform a multi-class classification, which we couldn't do because of how imbalanced the data was. So this is the ultimate goal of a future research paper. So thank you for your attention, and I will be happy to